All right, question 6. The sum of the first n terms of a geometric sequence is given by, and we're given the sigma notation for our sum to the nth term. Given that S sub n converges, find the range of possible values of C. So this is part A here. So I just wrote down the first two terms here in order for us to find R. So U sub 1 is going to be 5 times log base 2 C raised to the 0th power, so that just gives us 5. And then the second term will be 5 log base 2 times C, or log base 2 of C. So we can see that going from the first to the second term, what are we multiplying by? Well, we're multiplying by log base 2 of C, and so that is how we find that our R value, our ratio, is going to be log base 2 of C. Okay, so that was an important thing for us to realize. Now for convergence, we know that our R value, or the absolute value of our ratio, has to be less than 1. Another way to think of that is that our ratio needs to be in between -1 and +1, right? -1 and +1. And so basically what we have here is this idea that our ratio, log base 2 of C, needs to be in between -1 and +1, okay? So essentially we have our range here. We're given our range to be -1 to +1. So we're just taking a look at this chunk. So we're looking in between these two dotted lines that I've just drawn, okay? And we're really asked to find what is the domain. What is the domain that is going to be our C values? Well, we can see here that when I come down where I intersect with -1, we're actually at 1/2, at 0.5. Okay, so that's going to be the lower bound for C. And then here my upper bound is going to be 2. Okay, so we're just taking a look at those two X values, and those are going to be my C values. Okay, so for part A, we should get that 0.5 is less than C is less than 2. Okay, so that's part A's answer. Now moving on to part B, in the case where C is equal to 1.5, find the least value of n such that the absolute value of the sum to infinity minus the sum to the nth term is less than or equal to 0.1. Or sorry, just less than 0.1. So we know that the sum to infinity is going to be U sub 1, which we found to be 5, over 1 minus our R value, so log base 2 of C. Now C we know is 1.5, so we'll just plug that in. And we know that for S sub n, okay, that's going to be 5 times, now be careful with your parentheses here, this will be log base 2 of 1.5, all raised to the nth power, minus 1, okay, divided by then log base 2 of 1.5 minus 1, okay? So just plugging these two into our formula that we are trying to prove, or not our formula, but our inequality that we're trying to evaluate here. So that'll be 5 divided by 1 minus log base 2, 1.5. So that's our sum to infinity, minus 5 parentheses log base 2, 1.5, raised to the n, minus 1, all over log base 2, 1.5, minus 1. Okay, absolute value of that is less than 0.1. So to go ahead and solve this, you could use nsolve. However, it's probably going to be a little bit nicer if we were to graph it. And so if I go ahead and graph this in my GDC, okay, we can see that my blue line here, okay, this is my inequality, all right? My blue line is my inequality, so this is the left-hand side of my inequality. So that is my absolute value right there, okay? And then here I have the right-hand side, that is our 0.1 equals y, okay? So we can see that before our intersect here, our absolute value is actually greater than 0.1. Okay, so if I come over here to say 2, if I evaluate 2, well, my left-hand side, which is my absolute value, that is greater than the right-hand side, which is my 0.1. Okay, so we find that intersection point, and we can see that that is 8.935, dot, dot, dot. Okay, that keeps going. So we just need to think, okay, n needs to be, n is my counter variable, right? So n needs to be some integer, right? So we need to think, do I need to round this up or down? And this is why I like graphing, because here we can see that clearly we need to round up instead of down. So n is going to be equal to 9.